Hey everyone, welcome to Let's Create. This is a series where we take a character from a game and recreate those mechanics in blueprints using Unreal Engine 4. For this tutorial, we will be looking at Junkrat and his concussion mine ability. We are also going to be using a brand new project, something that is really easy for anyone to follow along with. All you need to do is go into the description and download the project that is linked. Once you have it downloaded, open the exe and you can join along with me. Every tutorial will be a blank project, so you don't have to worry about keeping up with every single one. This is the structure from now on, and I hope you appreciate the project. It took me a little bit of time to put together, but I think it's worth it. Anyway, let's begin with the lesson. Welcome to section 1 of this Let's Create. We're going to be setting up Junkrat and also the mine. To do this, we're going to first go into maps and duplicate this map. This is going to be our Junkrat_map. That way, if you do follow along all of these tutorials, you will have different maps for each character, allowing you to test them properly. The other thing we will be doing is going into blueprints, characters, and we're going to get this default FPS character, duplicate it, and call it BP underscore Junkrat. We're going to open this up. And as you can see here, these black colored nodes, which I colored over here, these are the default nodes that I have set up with you with these black comments. Anything we create will most likely have a white or gray outline. In the viewport, what we need to do here is we need to set up a location for the mines to be thrown from. This is quite easy to do, and if you go to Add Component and select Scene, this is the scene object which we can move and get the data from, so the world transform, and then spawn the mine from that location. Since this is the mine spawn location, we can simply call it the mine spawn location. We can then drag this out to somewhere around here, and this is something that you can obviously improve and make better later on once we have the mine to throw. Once you've done this, we're going to close this off. And one thing I want to show you is that with this new setup, when you drag a controller in, so one of these characters, if we were to drag the third person in and hit play, you automatically possess this character. In the original Let's Creates, we had to set up the game mode, but now with my new setup, we can easily drag in any character and play that character directly. So we can actually just drag in our BP Junkrat and bring it into the map now. With that done, the next thing that we need to set up is the mine itself. So let's create a blueprint class actor and call this the BP underscore concussion mine. We're going to visualize the mine. That way we can easily see it in game. To do this, let's call it the cylinder. So let's grab the cylinder. This is going to be the mesh mine, or the mine mesh. And over here, by default, you will have the snapping object selected. Let's deselect that, as if we were to try and scale this now, it's kind of going to turn out like a really flat pancake. We need a little bit of depth within it. So let's just bring this down and we can scale this in. And if you want to see what this looks like in game, we can drag this in here and then you can adjust based off how big you think you want the mine to be. You can of course come back to this after and fix it up. So something like that is good for me. And just in case you're curious, here are my settings, around 0.3. Now, with this mine, we actually need it to simulate physics. At the moment, if you hit simulate, it just stands still. If you were to turn on simulate physics and you have enable gravity, we can simulate and it will fall. And this is very important for when we throw out the mines. They need to move through the air but also fall according to the gravity. And the other thing we need to do is lock the rotation. We don't want it to rotate. We want it to just be thrown out and land straight. It'll make it a lot easier for us when we develop the mechanic. For everything else, we're going to leave it as default for now. And that is the end of the setup stage. In the next section, we're going to be spawning the mine, throwing it, and detonating it. We are now going to move into spawning the mine and detonating it in the second section of this Let's Create. Open up Blueprints, go into Characters, and let's open up Junkrat. Inside of Junkrat, we need to do one other thing, and that is to make sure that we make this a child of the camera. The reason being as if I rotate this down this way, or up here, the mine spawn location is here, which means my character wouldn't be throwing them up into the air. If I was to make this a child of the camera, rotate it to that same position, click on the mine spawn location, the character can now throw them into the air. It's the exact same thing as being able to say, turn around. My character can now throw them. Now that we've corrected that, let's go into the event graph and set up the mine spawning. To do the mine spawning, we need to set up an array. This array is for the concussion mines, so let's click variable. And let's call this concussion mines. And in the current version of Overwatch, Junkrat can throw 2 mines. You can throw one, detonate it, throw another. So what we need to do is have an array set up so we can keep track of how many of these concussion mines Junkrat has deployed. To keep track of this, it's easy to do it with an array. And it's also best if we change this from Boolean to the actual data type of the mine. So that's BP underscore concussion mine. Now, in here, we're going to get the left shift button, and we're going to get a branch. The reason we need a branch is because we don't want Junkrat to be able to throw an infinite amount of mines. And this comes back to the whole thing with the array. We need to make sure that Junkrat only has 2 mines out at a time. This is very easy to do, so if we drag this out and get the concussion mines, we can simply get the length. The length is how many array elements it currently has. 0, 1, 2. So that's how many array elements this has now. If I was to delete that, it has 2 array elements. Delete one more and it has 1. We need to make sure that it has less than 2 array elements, so it can go 0, 1, but it won't go to 2. Remember, 0 and 1 are 2 elements, and that means it has 2 concussion mines. All we need to do to set that up is make sure that this is less than and 2, and plug this in. If you want a Junkrat to have, say, way more than that, you could put in any number, 150 mines, but we're going to leave it as 2, and you can play around with that after. Once you have this set up, we can now get into spawning the actor. So let's drag out and spawn actor. Make sure you get from class. And this really handy node is going to allow us to select a class. The class we want is the BP underscore, and we're going to look for the concussion mine. The spawn location is the mine spawn location, which we set up earlier. The transform is actually, if we drag out, the world transform of the object. And we're going to not set it, but get the world transform. And if we were to plug this in, what would happen is it would get all the data. It would get the scale, rotation, and the location. To show you this, if we right click here and get the split struct pin, this transform data holds these 3 data types. We actually only want the location. I found earlier whilst testing, if you get the rotation, you can actually throw it like a frisbee into the ground and it will stick out of the ground at a weird angle. We want it to lay flat, so let's just split the struct pin and let's make sure we only get the location. Compile that to make sure there's no errors. And once we have this, the final thing we need to do when we're spawning the mine is to actually add it to the array. If we don't add it to the array, this length will never fill up, the elements will not add, and we could throw them forever. By adding to the array, we can limit the amount of concussion mines that we throw. So let's grab our concussion mines, make sure to get those, and we're going to drag out, type in add, and this simple node allows us to add to whatever array we have here. And what are we adding? We're adding whatever we want in this value here. However, it's not quite whatever we want. It is the data type that it needs. So if you see here, it's the BP concussion mine. We have spawned the mine. So after we spawn the mine, we want to simply add. And now it will add 1, 2, and then it will say you cannot add anymore. The next thing to do is to actually throw the mine, and then we can see if it works. So throwing the mine is quite simple. We need to get the mine that we just spawned, and we need to add impulse. And this will be add impulse at the mine mesh. By adding an impulse, it will send it flying forward. The easiest way to figure out where forward is to use the camera. So if we grab the camera, we can get the forward vector, which is the direction directly in front of the camera. No matter where you rotate it, it's whatever direction is forward for the camera. And we can simply times this by a float, and let's say a value of 2000 for now. Whatever you set this to is the amount it is going to fly forward. And we can throw this into the impulse. And by selecting velocity change, we can ignore the mass of the mine itself, and it just allows this value to be a lot lower. Without velocity change, you'd have to have a crazy amount of like 50,000 or 40,000. I just like to select this for the mine. So let's compile, and let's just comment these to make things a lot easier for ourselves to read, and in case you want to revisit this one day. So this section here is all about spawning the mine. So let's call this spawn mine. Apart from spawning the mine, it also has logic to make sure that we don't have too many mines, but it can all kind of fit under the same category. This section over here, once we've spawned it, so this is kind of awkward in the middle over here, but this section over here is to throw the mine. And now we have these two sections. Now, the next thing we will do is actually blow up the mine, but let's make sure this works first, that we can throw it, and that only 2 of them spawn. So let's hit play, maximize the screen with F11, press shift, we get 1, 2, and that's it. Now we can't detonate them at the moment, so they're just going to stay there. So let's test that one more time. And because of the physics, let's have a look. 1 bounces off, and let's look up. Let's actually look the other way. And there it is. So we can throw our mines around. Let's move into detonating the mines now. So to detonate them, we want to open up our props. And whilst you're doing all this work, make sure that you're constantly saving everything just in case something happens. Let's open up the mine, and we don't need any of this. We don't need to work in this specific event graph at all. We're going to create a function. This will be the detonate. So detonate. And in this function, we're going to blow up the mine. And part of this is actually figuring out how can we apply a force to the objects around us. Well, to apply a force to the objects around you, you need to know what objects are first around you, and then apply an impulse to them of some sorts. The one way, there are lots of ways we can do this. One way that I want to use and show you is the multi-sphere trace for objects. So let's type that in, multi-sphere trace for objects. Now this is going to check for multiple objects within the sphere that we're going to spawn. So let's drag this out. The start and end location is just from the mine mesh, and we can simply get the gut world location. And we can drag this in to both of these vectors. We can set the radius for now. Let's do something like 800. And let's actually persistently debug this whilst we test. The other thing is that we have this error. It's because we haven't set any object types. So if you drag out and you'll see make array here. Let's click that. And we can figure out, okay, what type of objects do we actually want to trace for? So let's add a few pins. Let's add 3. We want to check, first of all, for the physics body, because a lot of our objects have physics body. If we were to click here and look down here, this is the physics actor, and if you see the object type, it is actually physics body. We don't want world static because we're not getting static objects, so the next one we need that's common is the world dynamic. And of course, the last one is the pawn, which is what a lot of the characters will be using. Now that it knows what object type in the collision to look out for, we can set this up. So we only want to do this when it has returned a value. And once it has, from out hits, we need to get a for each loop when it's true. And if you double click, we can make these nodes to make it a bit cleaner. With this for each, we can check for every object type that this sphere trace picks up. We can check each one of them, and we can apply various things such as physics. We can impulse and move them. We can do a lot of things depending on the object type we get. The very first object that we want to concern ourselves with is actually Junkrat himself. So from the array element, let's do a break hit, and this is going to give us a lot more channels to work with. One of the channels we need is the hit actor, and this allows us to cast to the BP underscore Junkrat. Once we've casted to Junkrat, we're going to do a few things which will allow us to launch the character. Now, this is a very flexible system that I've created, and you will have a lot of variables to mess around with. When we set this up, we need to have 2 things. So when you're moving on the ground, your character has friction. When your character moves through the air, they do have friction if you set it up. But too much friction looks a bit unrealistic, so I figured out a method that works quite well. This is, by the way, just one way to do it. There are lots of ways to do it. If we were to grab the BP Junkrat and get the character movement, it would give us access to something called is moving on ground. Now, as I mentioned, this detects if you are moving on the ground or if you are in the air. And the way it can tell is if we get this branch and drag out here. If you are moving on ground, it will be true. If you are not, it is false. If you are moving on the ground, we need to have a higher value for how we launch you in the air. If you're not moving on the ground, we need a lower value, I should say, for launching you in the air. As when you're not in the air, you don't have the friction, it will send the player flying. If you are on the ground, and you launch at a lower amount of force, you will not fly out properly. And you'll see that in action now. So let's get into this. Let's drag out here and let's get the actor location. And what we're going to set up here is we need to figure out what direction the player is going to be moving in. So up here, let's set this up. The easiest way to figure out the direction is to minus the player position. And the way we minus it is from the actor that is going to be throwing us away. So if this was an enemy, it would be the player position minus the enemy. In this case, it's the player position minus the mine. Of course, we need to normalize this value. And from here, we have set this up pretty nicely. So this will be a comment. So we just highlight it, press C, calculate, direction. I'm just going to move this out of the way. Now that we have the direction calculated, when this is true, we're going to use something called launch character. It won't come up. That's because we need to get it from here. So launch character when it's true, and launch character when it's false. The way we're going to launch it, and if you actually wanted to keep this really neat, you can double click, drag into here, just bring this down, and we can do a similar thing here. Let's actually break the links and bring that in. Awesome. From up here, we can get this result and we can actually times it. And we're going to do something very interesting. So if you right click and split the struct pin again, you will see that, we'll do it for both, you get the X, Y, and Z. Now, we need to manually set one of these values, and we need the other values set depending on what direction we're being launched from. Z is up, and that is how high we're going to be launched upwards. X and Y are the ones that we need to calculate what direction we should be launched in. Up is always up, right? So in case of how this works. So we're going to set this to like 3000, and that will send us up by 3000 in terms of the force. Now from here, we can times this by a float, and this number here is how far we'll be kind of launched for the X and Y. So we just need to split this and plug it into the X and plug this into the Y. And we can just drag this down here if you like. We need to do the exact same thing for this, but this time it's when we are on the ground. So 3500. And actually, sorry, this is for when we are not on the ground. So 3500 is important because when we're not on the ground and we're falling down, we need that extra 500 to launch up a bit. The other thing we need is, of course, to times this again. So let's drag out from up here and times it by a float. We can split this again. Whoops. Split, plug in the X and the Y, just like we did before. Now, before we had 4000, this time because we're in the air, we can have a lower value of 3500. And if this feels too strong to you when we test it, then you can easily just set this lower and you can set this higher. And I'll show you how to expose these later so you can change them much more like a designer. Now that you've got that set up, we can highlight this, press C, and this is to launch Junkrat. And over here, this over here is to kind of find Junkrat. It's to find objects within the trace to detonate, to launch. The very last thing we need to do is launch the physics objects. So apart from Junkrat, there will be objects that you need to launch, such as cubes. And these various objects will be simulating physics. So the best way to move forward is to actually branch out. And we just want to check if the component, so the components, is simulating physics. We can then chuck this into the branch. And from here, if they are, we can simply add a Radial Pulse. We don't want to do it to this object, however. We want to add a Radial Pulse to the objects that are being that are in the array, the current object in the array. So we need to get this hit component again, which we should be able to just access from here. Add Radial Pulse. Impulse, there we go. Drag that into true. And the origin of the impulse is actually from the mine mesh, because that's the object that is going to emit the detonation. So let's get the world location, plug that into there. The radius is how far it's going to shoot this radial impulse from. So if you're within the 600, you're within the blast range, and you will be hit by the amount of strength. This is going to be something ridiculous because if we're not going to set the velocity change for now. So let's say we do a value like this. And the only other thing is that once all of this is completed, we're going to test this in a second. Once we've done all of this, we need to actually destroy the mine, which is as simple as destroy actor when completed. And yeah, that's it. We can actually go ahead and test this. This last section is to launch physics objects. So we figure out what objects are within our radius. We launch the character based off the direction and based off how high we want them to go. We also then launch the physics objects from the mine's location by this much radius and this much strength. Awesome. The last thing we need to do is actually call the detonate event, and that is very easy to do. We just go into characters and Junkrat. To detonate the mine, we're going to get the right mouse button. We're going to get a branch, and we just need to make sure that there are mines to detonate, or else there's going to be a ton of errors. So to do that, get the concussion mines, get the last index, and check if it is greater than or equal to 0, because remember, if it is equal to 0, there is one array element in it, based off what I showed you before. This is just to check. So check if the array is empty. Then we can simply detonate the mine. So grab the concussion. We can get a copy, element 0, which will be the first one in the list. We can just call detonate. And we can simply then, after we detonate it, remove it. So let's do remove, let's double check this, remove. Should be fine to remove item. Plug this into here, and then plug detonate into remove. And now we should have everything set up, so let's compile and save that, and let's test it out. So hit play, throw a mine. Whoa, got launched heaps far. Oh yeah, there is actually one other thing, but it is working. We can throw them and detonate them. There is something I forgot to show you all, and that's the reason why the character is going flying at the moment. On Junkrat, if you go into character movement, there will be a, it should be in here, there we go, lateral friction. If you increase this to 1, you'll notice that Junkrat won't go flying as much. And that's because he actually has friction when he's moving around. So you see it's not as crazy, you kind of stop. If you want more or less of this, you can just simply change the friction amount that I set here. I'm going to leave it at 1. Potentially 1.2 to 1.5 might feel really good as well. The other thing we wanted to test was to make sure that the props would move. So let's go to the props folder and let's bring in some of these physics cubes. These were pre-made, so you can just bring them in, bring in a few of them, duplicate them around, and there we go. Let's throw a mine in, right click, and nothing happened. Yay! Let's see why. So whoops, let's go into the mine, and let's make sure that we've got everything set up properly. So if it is simulating physics, let's make sure it is simulating physics, just in case I missed that. So it is simulating physics, it is a physics actor, yep, and it's got gravity. It is also generating overlap events. Let's make sure that I have the right connection here. So instead of component, let's get the actor and plug that in. No. Okay, that is fine. So it should be fine with this component reference. We can add in a print to make sure that it is going forward. So let's print this and make sure. Ah, that's interesting. So it's not actually saying that the object is simulating physics, which is a bit odd. And, oh, I see why. That was a very simple and silly mistake of me. This function is only being called if Junkrat is found. So if the cast is failed, if we can't find Junkrat, it's not going to do this branch. To fix that up, we just simply go from cast failed into this branch. So let's try that again. Boom, there we go. And we can shoot ourselves in the air, and we can actually do it in midair, which is awesome. Now that we've fixed that up, we can disable the persistence to none. And one other thing is, if we don't hit any objects, let's just destroy the actor as well. That way the mine isn't left over. And one other thing to show you all, let's see if this happens. If we put two mines next to each other and right click, you'll actually notice, whoops, let's do that again. 1, 2, right click, 1. Now you can only throw 1. What's happening here is actually that second mine has gone flying. And it's because the physics are actually interacting with each other. So the easiest way to fix this is to grab the concussion mine, and it might look a bit silly, but let's go into the collision presets, custom, and let's change it to vehicle. The reason why this will work is because we are not checking for a vehicle, we're checking for the physics body, while dynamic and pawn. So by making it a vehicle, if I was to add 2 of these now, the last one stays over, and there we go. So yeah, that's it. We have our mines set up, and if you'd like to test this further, you can bring one of these blocks out, so duplicate that, and you can make a little kind of course to test yourself. The other thing I wanted to mention is that we don't have a cooldown, and that's kind of a challenge for you guys to make. So I want to see if you can all make your own cooldowns. That's why I didn't include it. It's kind of like an extra activity to do after the tutorial. So go ahead and try and make a cooldown for the mechanic and see what you can accomplish. That way you can not just consistently spam these mines. Thank you all so much for watching. I hope you enjoyed this Let's Create. If you did, make sure to subscribe for similar content. Let's Creates take me a long time, so I create these usually once a month, maybe once every 2 months, and in between I create a lot of other content whilst I work on my games full time. But I really wanted to create one for this month. It's Christmas, it's been a long time since our last Let's Create, and if I can do it, I'd love to create one more for all of you this month. So let me know what mechanic, what character you would love to be created the most in the next Let's Create. Anyway, thank you all so much for watching. I hope you all have a great weekend, and I will see you all in the next video.